So, thank you for joining, and I suggest we start. And again, I hope you will hear me. Fatih, if you don't hear me, please just call me. Oh, thank you. Oh, yeah, he sent me a nice message. Okay, good. Yeah, it's always a bit uncertain, and I like uncertainties. Okay, good. So it's called SimOps, Simulation Operations Automation, and we will go into some detail. It is about industry recipes for simplifying operations and use of the underlying infrastructures for complex engineering simulations. And especially about the practice. So how do we do that, right? The practice of automating processes that run simulations to dramatically increase engineers' productivity and the contribution to the company's innovation. Okay, so very briefly about the presenter. Okay, so the host, that's me, Wolfgang Gensch. I'm the president and co-founder of Simmer, formerly known also as Übercloud. And obviously, I'm a great SimOps advocate these days because SimOps is brand new. And the predecessors with a similar focus are not brand new, like DevOps, FinOps, etc. But SimOps is really brand new. It's, I would say, 4 months old. Okay, so welcome. You were one of the very first ones to get really close in touch with it. Okay, yeah, I should change that picture. The other one was a sketch which an artist was drawing at the supercomputing show, and I mean it's very close, right? So just tell me, right? So yeah, okay, good. So yeah, let's continue and have fun. And we continue with a short SimOps history. And it started basically at the early days of our company's foundation. In 2012, we started the so-called Übercloud experiments. And so far, we did over 230, exactly 232 experiments, cloud experiments, taking engineering simulations to the cloud, learning a lot, helping them to understand it, giving feedback, and putting all the challenges together and finding solutions for these challenges. So that was over the last 10 years then, right? And as you can see on the right-hand side, there are a few of these compendiums, all with 10, 15, 20 case studies, which we did. And if you send me an email, or if you're interested in some specific ones, for example, this one, the machine learning one, or this one looks like the energy one, yeah, so energy applications, then this is healthcare applications, and so on, right? So there are over 150 case studies, which we have sorted into different areas, so you can see your favorite applications. Just if you send me a little email, wolfgang.gensch@simmer.com or simops.com or übercloud.com, it's your choice. Okay, so then in 2015, we did the first collection of these lessons learned. And yeah, during that time, so after that, we learned especially from our industry customers. And so some of our customers are among the so-called Magnificent Seven. And so the most valuable 7 companies in the world are, so part of that, 3 of them are our customers. And in the early days, they gave us a ton of feedback, and which then converged into basically SimOps. Last year, so far, then we had 230 engineering cloud projects, 150 case studies, and we collected a long list of best practices out of each of the case studies, and we condensed the best practices into specific areas, right? And last year, also in May, we started preparing the SimOps, the SimOps activities. And our company is then Übercloud, now Simmer. And in my humble opinion, Simmer stands for simulation ready, because what we have built in that company, and please, SimOps is independent from that company, right? And we go into some of the details. In 2024, what happened was we renamed Übercloud into Simmer, Simulation Ready Platform. developed the SimOps framework, wrote the SimOps ebook with all the details of this whole process of SimOps. We'll get into details then. And published the very first SimOps fundamentals training. So far, we did about 100 something trainings and certifications for members of our HPC CAE AI community. And we announced the SimOps community finally in September 30, and we celebrated it at the Supercomputing Show. And currently we are founding the independent nonprofit SimOps organization. Okay, so that was a piece of the history. And the final very important activity is we identified, we found that DevOps has a lot of similarities. But while DevOps founded in 28 around, when there was this new wave of continuous development, right? And the IT people were overwhelmed. You know, there was no longer a release, a software release every half year or so, but 2 releases a day or so. And the ops people, the IT people, they couldn't catch up. Right? So the developers came with new requirements every day, several times, and the IT people. Okay, and then some clever people decided to set up DevOps, which is combining, bridging the gap between the developers who usually are or were a silo, right? And the IT people. And they didn't collaborate and communicate often enough. Right? And that was the major aim of DevOps, right? Combining the software developers and the operations. And the aim was to increase efficiency, speed, security, etc. So now you see the similarities. So in SimOps, we don't have the dev people, but we have the sim people. So the simulation engineers and the operations people operating the infrastructure for the simulation engineers' applications. Right? And so again, same situation. When we go into a potential customer meetings, then we very often recognize that the simulation engineers and their managers sitting on one side, the IT people, the operations guys, they sit on the other side, and maybe there is 1 or 2 decision makers, mostly not, right? Which is also a problem or a challenge. So SimOps aims at bringing all that together in a not continuous development, but in a continuous communication, right? So you see the similarity with that one. And now, yeah, let's go into the details. Why SimOps? I mean, I mentioned a little bit, you know, the miscommunication very often, or the silence between the 2 silos. So what are the major challenges these groups are facing today in especially larger and larger companies? I mean, small companies, so one engineer is, you know, is sitting on a workstation, and she is at the same time the operator and the decision maker. Okay, we don't talk about that one, right? We talk about larger enterprises, companies that where it makes a real sense to basically bring everybody around the table. Yeah. So okay. So number one, there is lack of common shared perspectives. So every stakeholder, so the engineers, the IT people, the decision makers, they have different views. And because they don't meet often enough, they cannot often really efficiently come together. So the other one is the result of that, there is a lack of cross-functional collaboration. Okay. And then there is obviously the engineers' requirements lead to highly complex HPC CAE cloud infrastructures. They have engineers have very complex applications. They have multi-physics. They have complex workflows from pre-processing, sort of 1, 2, 3, to post-processing, to remote visualization, etc. And then, by the way, very often these days even start to implement a machine learning loop around it. So this complexity is a real challenge, not only for the engineers with their simulations, but especially also for providing the infrastructure on the operations side, on the IT people side. And then we have limited HPC resources on premise, especially, right? So there is long queues, long waitings, and limited resources. So very often you can only do one simulation at one after the other. You want to do 10 simulations because of the parameter studies. You want different materials, etc. It's all the same simulation, but slightly modified parameter set, which you could easily execute in parallel, right? And so it's limited resources, and we will talk about obviously the solutions to that one. And there is a missing concept for data protection. Data exploded in the last few years, and there is compliance issues and also the challenge with disaster recovery. So there's a lot of challenges the engineers, the IT people, and the decision makers have to cope with. And finally, last but not least, we don't get enough experts anymore in the combined area of engineering, high performance computing, cloud, and IT operations, and now AI. Right? So it was amazing when I was at Supercomputing in Austin 2 weeks ago. It was on every corner. It was cloud, AI, cloud, machine learning, cloud, etc., right? And a ton of, I shouldn't forget quantum. Okay, yeah, but this is a different topic. We might have quantops in 2 years or so, right? Because I can see that in the earlier days of these new waves, then they all will basically repeat the same challenges, or face the same similar challenges. Okay, so how do we solve these challenges, or how SimOps aims at solving these challenges? Okay, bridging the gap. We said stakeholders. So there is common goals, develop common goals and processes, and facilitate cross-functional collaboration. So the next one is automating the operations for these complex environments, which we identified as a challenge. Right? And then the other one is easy access to agile resource infrastructures, so that engineers can really choose 1, 5, 15, 20 different servers where they run 20 different simulations in parallel, and be 20x more productive, right? So 20x means 2000%, right? Because they run in one, instead of one, they run 20 now. Yeah, often. We have one customer where the engineering manager says, I have engineers in my team that are 42 times more productive. And they use a SimOps compliant platform, right? So, okay, but this is the top of the top, right? Usually we say 5, 10, 15 is a good average. So providing matrix is very important. Working and providing matrix to be able, I mean, without matrix, you cannot improve things, right? So to measure, report, and understand the results. And then there is data protection, as I said, ensure data protection, compliance with regulations, etc. Finally, again, so the skills gap, bridging the skills gaps by what SimOps is offering, namely trainings, training. Within the SimOps non-profit organization. And we started with, I will get to that, with the SimOps fundamentals and later on. So one example, I mean, this is very easy. So to make SimOps a little bit more concrete, right? You know, these are all methodologies and cultural changes, by the way, within an enterprise. And so some concrete things is SimOps, definitely, and there are nice examples at the end. I hope I will come to that. If not, you will get the slides anyway tomorrow. So SimOps can increase your engineer's productivity, say, by a factor of 10. Okay, so what does it mean? So getting to new product designs, the engineers, they do a final design and then throw it over the fence to the people who produce the product, then the final design. Usually with quite or highly complex products, such a design it takes about 3 to 6 months to be production ready, right? So ready for the production people, right? And what that means is with SimOps and a factor of 10, you can get a new design into production readiness in 2 to 3 weeks, right? So absolutely amazing. And now we are on our way to learn how. So, okay, so let's look at the highest structure of it. And it says SimOps redefining simulation operations. So we talked about the challenges just right now. Okay, so this is done. And then the next one is the best practices. As I said, we collected about 40 plus different best practices out of our so-called Übercloud experiments. And they all ended with lessons learned and recommendations. And out of that, we extracted the best practices and melted it down to 6, 7, 8 topic areas. So like, simulation-driven decision-making, or the second box is about manage, optimize, monitor the costs and the resources and retain control. So these are all very important practices which we want to realize. And finally, we are, SimOps is basically helping the teams to build like a SimOps engineer, the SimOps IT specialist, and then there are decision makers who are participating in, let's say in the teams, so that which is the second box here, so there is the integrated SimOps teams with the members of the engineering, the IT, and the decision-making side. They all should regularly come together. So to early enough identify challenges and with the help of SimOps and find the right solutions and the right process. And the impact is in very short, right? So breaking down silos, a shift left approach. I mean, start simulations as early as possible and avoid failures in the very early phase of the simulation by doing more simulations, more than before, much more than before. The more you do, the more you can discover failures, and also you can improve the quality of the results, right? And then again, increased automation, trying to avoid as many manual interactions as possible, and then creating and getting continuous feedback. And you can only do this when you have everybody in the room, so to speak. So regular meetings with different roles is of utmost importance. So the SimOps principles, which are part of the SimOps framework. So we call it a North Star. When you look into the circle, then the SimOps principles are defined as a foundation for guiding. So these are guidelines, right? For guiding efficient collaborative simulation processes, right? And which are these principles very quickly? So simulation-driven product development, right? So the simulation is number one, is the key of the whole process. It starts with always with the simulations-driven product development. The next one is automate simulation workloads. So the engineer on top of the infrastructure should try to automate the simulation workloads, right? So not moving data from solver 1 to solver 2 manually, but or automatically. So the whole workflow from pre-processing to post-processing, remote visualization, machine learning loop, etc., ideally should be automated. And so the next one is operational efficiency using hybrid cloud practices. Hybrid, because very often what we see is engineers and their managers, they decide which of the data has to still be, for some good reasons, on premises in the company, and which one can be moved to the cloud. This is lesser and lesser important because it is possible today to develop an integration between on-premise and cloud, where the cloud is basically a private cloud, which logically belongs to the on-premise, right? But it's sitting in the cloud, but it is end-to-end securely connected. And this cloud part is owned by the engineer who is doing the simulation, either on-premise or in the cloud. Very often in SaaS solutions, this is not the case. The SaaS solutions usually are controlled by the SaaS provider because it's the SaaS provider's resources and the cloud account, which the SaaS provider obviously controls. But if control is not a major concern, then it's easier to use a SaaS which is basically ready, like take, for example, Ansys Cloud, which is a great add-on to the Ansys graphical user interface, for example, for Ansys Fluent. And with one click, the engineer can send the data which he has prepared on premise, on the workstation, for example, with one click into the Ansys Cloud. There is nothing more elegant than that one, but the control, the exclusive control, there's no exclusive control for the engineer. It's usually that. So there are different levels of maturity, and we will get into that one, right? Okay, so the next one is retain control of proprietary data. Okay, so that's important. Next one is manage and optimize costs and resources. Cost control is extremely important on premise as well as in the cloud. So there is no difference. So but you are used to do cost control very often in larger companies through the IT department, and then reports, weekly, daily, even reports, often go to the manager, so that they are used to do that. And there are cloud service providers who have done basically the same in the cloud. So then there is cross-functional collaboration, as we already said, with the different constituencies, and finally simulation-driven decision making. A decision should be driven by the simulation results and by how these results have been produced. Right? So that a process, doing simulations enough, yeah, good enough, accurate enough, quality enough, then and to provide the results then to those who make the decision. Okay, so now, as I already mentioned, there are different maturity stages, right? We call them prove, scale, optimize. You could them. I mean, you might better know something like crawl, walk, run, right? And so this is proof is an early phase. So no compromise engineering experience. So the ideal scenario here is that engineers' work patterns are not disrupted. Yeah. So ideally, so when you move an engineer's simulation in the cloud, the engineer's work patterns should be basically, ideally should be identical, right? So that there is no learning needed. So that's meant with that one. Then fully leverage cloud capacity and capabilities. You get a lot of good stuff in the cloud, right? Be it compute, network, storage, etc. So you have a wide variety, and very often you need help. And it would be good to get this help. And SimOps says, work not only even on premise together, so in your company, together with engineers, managers, IT people, etc., but also with the people you bought the tools from and you get the services from. You definitely want to leverage everything where you could get your hands on. So scale quickly conforms to enterprise IT requirements, increase organization-wide engineering productivity. So that's on your way to the final stage of maturity, and where you drive cost optimization. So drive cost optimization, model cost and performance, and measure against enterprise KPIs, right? And then make simulation-based decisions, integrate simulation into up and downstream processes. Okay, so these are the major maturity stages, and you can certainly look into the white paper, which you can download from our website, about the SimOps framework. The SimOps framework explains very accurate all the different steps which are necessary, and which you basically can copy paste then for your own company intern process. Right? So we talked about, on the left side, you remember we talked about the SimOps principles and the stakeholders already and the different maturity levels. And then there are 4 major domains which you have to take into account, which is simulation side, the data side, the compliance side, and reporting, etc. Right? It looks a little bit different when you go into more detail, and that's why I showed you the previous slide first. So it's not complicated, but it's complex, right? Okay, there is a lot of things, but this is a very nice guidance where you can really go step by step and build a little process for each of it, so that you can follow in different teams then the realization of it, right? So all these details are discussed in this, on the bottom you have the link, the framework white paper, which you can download from the simops.com website under resources. So for you in the beginning, you define a benchmark table, right? So the capabilities which are important for you, right? Which are part of your goals, right? Then you want to put on the left-hand side. For example, replicate internal engineering experience in the cloud. This means in the ideal scenario that your engineer's work pattern is identical on-premise and in the cloud, so that the engineer doesn't have to learn additional cloud tools and access and portals and so on, which simply distract them from their real task of doing the simulation and working on the next generation's products design. And a low performance start, for example, very often in many companies, it is like that. So engineering work patterns are disrupted. So when you use a SaaS solution, for example, software as a service from a SaaS provider, the engineer has a different look and feel, because he's submitting the data through the SaaS portal, which usually is very different from what the user has developed, or the IT people have developed for the user, for the engineer, over the last 10, 15 years or so, right? And okay, so in full, this is one example which we provided here for your guidance, how you select your major capabilities. So what do you expect from like workload and cost optimization? Yours could look very similar, because these are real major concerns here, which the capabilities of which you see here then resolve the challenges we talked before. And these are examples for low performing, for basically starting into the SimOps process. And this is your end goal, so to speak, right? Real-time visibility into performance and cost KPIs, for example, here, and so on, right? So yeah, so we still have a few minutes. I'm almost done. So your journey to SimOps is straightforward. I mean, it's with any new project, which is a little bit more complex, etc. You assign engineers, managers, IT specialists, decision makers, etc., and follow the SimOps ebook guidance here, and then build integrated SimOps teams. And in larger companies, even a SimOps center of excellence. Right? And then you do a benchmark, you self-assess, number one, yourself about HPC, CAE, Cloud, AE, SimOps, etc. And you do a self-assessment for your company. That's where you start. So first is self-assessment, and then successively, once a week or once a month, as you like, then you benchmark it and you check, you measure if you are getting closer to the optimum, to the SimOps high-performing situation. Okay, so let me get back. And then, so benchmark, develop processes by applying SimOps framework and integrating advanced technologies, optimizing workflows, fostering cross-functional collaboration. So these are all major activities which are explained in very detail in the white paper and in the ebook. And finally, select and implement the best suited approach to simulation platforms. So what is the best software you can use immediately and run? Not reinvent wheels or try hard to avoid do-it-yourself. McKinsey says about 80% of do-it-yourself projects in this specific area, they fail. And if they fail, then the team will never look at a better solution, so to speak, for example, cloud solution, again, for the next few years, right? So that is lost time, wasted time. Step one here, realistically concrete, there is for individual people in your company, select 3, 4, 5 or so, should do the SimOps fundamental training and get the certificate. So you learn about the fundamentals of SimOps, and there is a personal assessment about HPC, CAE, Cloud SimOps, AI. In the meantime, also we added a few questions there. Answer 40 multiple choice questions and get certified. Right? The training and the certification takes 1.5 hours. It is a very first step into SimOps, and you see the next ones we are preparing is the SimOps practitioner, the SimOps expert, and the SimOps architect. And especially also please then, if you do that, provide feedback to our SimOps team, to our own SimOps team, so that we can improve these trainings. And if there is things missing, then we want to add it certainly. And so the access to this free and online SimOps fundamentals training is again on the SimOps website under the certification tab. So I will skip this last part, which is examples, SimOps in action, right? For example, SimOps in the aerospace industry. So we selected a few customers and looked at the customers who are already at the highest level of maturity, who are really completely SimOps compliant, right? And so the aerospace, so the automotive industry, with the improvements mentioned by some of their people, and the biomedical engineering, that's a living heart project, the mitral valve defect, repairing this 40% reduction in time to market, blah, blah, etc. Consumer electronics in Silicon Valley, large company, cost reductions and improved product reliability and so on. So there is a comparison of SimOps here on the bottom with the existing engineering organizations, NAFEMS, ASES, and RevSim, Revolution of Simulation. And while the three ones are looking at the simulation level, the application level, SimOps is looking at the infrastructure level and how it integrates and interacts with the application of the engineers. And with that one, there are a few sources and references, and this is my last slide. And I would like to thank you very much. And I want to stop sharing to see if there are questions. And let me see, there was here on the right-hand side, I'm seeing here Q&A. And so far, Q&A. Please, if you have a question, select your questions. We still have, we still have a few minutes, and I invite you to ask your questions. And it looks like a lot of good information, and the guides which I mentioned to you. So the SimOps framework and the SimOps ebook, they take you basically, they guide you step by step through this whole process. So it entangles the complexity even in this information. And if you are familiar with DevOps, and I'm sure many of you are, I should mention that I checked in our own company, and all the operations guys, the developers, and the service guys, the Q&A, sorry, the quality, the QA, not Q, the QA guys, they all said, yeah, DevOps. From the very beginning of our company, we have developed DevOps processes for developing the best possible software, so with highest quality, so that for the customers. So this is an example. I mean, this is in many organizations like that, to really get also implement this continuous development process, then with even daily releases, leads to very good software and products, so that our customers get high quality products. And now, so that is with DevOps. And with SimOps, so with SimOps, which we help our customers to implement these processes, to reduce friction in the company and to increase the efficiency of the engineers and IT people to work on the real thing, so to speak. So both things are basically very important. DevOps for the product side and SimOps for the process and communication and optimization and automation side, not to forget. What cloud service provider does SimOps framework works? Is this tied to any specific or limited to specific? This is a great question. And usually, if I'm really kind of a nervous guy, I would say, this is maybe competition, but there is no competition, right? For every approach, even for the SaaS approach, if you have specific requirements and others not, for example, if you don't care about having full control from A to Z, right? Okay, you want to hand over your data and are only interested in the results, and losing control for quite a while your stuff is running in the cloud, your simulations, you don't care. So then that is your maturity level, right? If it's done fast and automated, ideally, like I mentioned, the Ansys cloud, right? So one click, your data moves to the Ansys cloud, and then you get the result back and can continue working on premise, or for example, on your workstation. Okay, so even Ansys cloud is SimOps compliant if, right? So that there is one company that I know where there are no ifs. One company that provides a highly flexible tools layer, platform layer, fully automated. With one click, you're in the cloud, and then 7 clicks, you set up your cluster with the right instances, etc. That is the highest maturity level, which is well suited for very large companies. So for companies with 10,000 and more employees, for example, where you have 100 or hundreds of engineers doing simulations, you need this flexibility, because these engineers, they run 25 applications from 25 different vendors, right? Like Ansys, Dassault, Siemens, etc., right? So you don't need 20 different clouds, SaaS clouds. So learn 20 different clouds, that would be crazy. You need one set of tools, which then embrace everything. So which is ideally application agnostic and infrastructure agnostic. Yes, there is one company. Okay, so good question. Thank you very much. I think that if you don't have anything else, that was a great question to complete and finish this webinar. For me, it was a lot of fun. So I hope you enjoyed it as well. And also, please, if you have more questions, and so just please send it to me. And then I want to take the time to Dennis. Our partner Activeon with a very nice development ML AI library and integration tool, just integrated this with our Simmer platform, and now this is basically a complete development and design platform together. Thank you, Dennis, and have a great day. And I wish everybody, yes, a wonderful day wherever you are. For me, it's time to go to a good glass of beer. You know, I'm sitting in Bavaria. I have to. Okay. So I wish you all the best, and thank you so much for joining. Bye-bye.